Okay, so this morning we're going to talk about triangle congruence. Okay, now we found out that for triangles, you don't have to have all 6 pieces to show they're congruent. We need 3 pieces, so we must have always 3 pieces. Okay, so we need 3 pieces. Okay. All right, always 3. Always 3. Okay, now, 3 we've discovered are side, side, side. That says if 3 sides of one triangle are congruent to 3 sides of another triangle, triangle are congruent. So if 3 sides of this triangle, this side is congruent to this side, second side is congruent to second side, third side congruent to third side, these 2 triangles are now congruent. Okay? It means that these sides, being the length they are, locks these angles into certain values, and their values are both same, so it makes the angles become congruent also. So having those 3 pieces makes those triangles congruent. There's 3 of these. Okay? There are 4 of these. Okay, so the second one is side angle side. Now this angle here is between the 2 S's because it's an included angle, so it has to be between the 2 sides. So included angle means it's between these 2 sides. It sits in between those 2 sides right here. Okay? So side angle side, side angle side. If they both have the same construction, the same 3 pieces, and they're congruent. Okay? And that's what included side means. Included side means it's got to be between the 2 sides. Okay? And that's why the A is in the middle of the 2 S's to remind us to do the included side. Same thing happens here. We have angle, side, angle, and that side must be the included side between the 2 angles. Okay, so 2 angles in the included side of one triangle are congruent. 2 angles on one side of the second triangle are congruent. So we have the included side is angle here, and then the included side is between the 2 angles. So angle, side, angle. Okay, and the last one of the 4 main ones is angle, angle, side. Now this means, because this S is outside the side, this is a non-included side. Okay? But it has to be the corresponding non-included side. Because there are 2 of them that are non-included. Okay? So even though this is the side that's next to the angle 2, these are angle, angle, side. So this is, but there's also the side down here that can be the non-included side. So they must be the non-included side. Okay, or the non-included side, but they got to be corresponding. Okay, or that side. Okay, so it can be either one or the other, but it's just got to be 2 angles and then one of the non-included sides. But it must be the same side. You can't mix them up. Okay, so that's for those are the main 4, and we use those pretty religiously about finding triangles that are congruent. Now for right triangles, there's 4 more, but we only use 1 of them really, because the other 3 can be tagged to one of the main 4 we did before. So first off, the right triangle we talk about, has to know what the names are here. So on a right triangle, this is the right angle. It means it's 90 degrees. Okay, and the side opposite that is what they call the hypotenuse. Okay, so the hypotenuse is the side opposite that 90-degree angle, and that is the longest side of the triangle. The other 2 sides are called legs. Okay, all right, so that's how we do it. So we have an angle in the 90-degree angle already. We know that the 90s are always congruent. So when we do, like, we come over here and look at leg, leg. Leg, leg is one of the rules for right angles, but if you look at it, it's simply just angle, side, or side, angle, side. Because the 2 legs and the congruent 90-degree angle make it side, angle, side. So, same thing. You can call it leg, leg, you can call it side, angle, side. It doesn't matter. It proves triangles are congruent. Okay? Okay, the other one, second one we have is hypotenuse angle. Hypotenuse is, of course, the long side, so have to have a hypotenuse and one of the other acute angles, which is the same thing as having angle, angle, side, or angle, angle, side. Okay? So That matches up pretty well. Excuse me. Okay, the next one is leg angle. Okay, and if we have leg angle that's on the same side as this leg, then it will be angle side angle. But if it's on the other side, okay, let's say we have this angle over here on that leg, then it's angle side. So it could also be angle side. Okay? And we don't use those very much. We do use this in a whole lot. That's where your assignment's going to have a position here. It's hypotenuse leg, and it's there's nothing that's matched up to it. Okay? It's hypotenuse and leg, and it doesn't matter which leg. And this is actually one thing that works. It's because of the Pythagorean theorem that forces this to be worked true. But it comes in as angle side side. But angle side side normally doesn't work. Okay, so, alright, whatever it is, angle side side. So, this is what we're going to practice on today. You have to have a 90-degree angle and a congruent hypotenuse and a congruent leg, corresponding leg. They're congruent. Okay? Alright, and it shows them three congruent. So two that don't work, people think they do. I think that angle side side should work. It doesn't work, and angle only works for what is that called? Similarity. So this will work for similarity, but will not work for congruency. Okay? Alright, so I suggest you keep this paper around where you can see it, especially these four, so you can see these and see how things match up. Okay, so here we go, page 2. Alright, number 1 here, top one here in the corner. Okay, what I see here is I look at the marked sides only, so I have the marked pieces only, so I know they're congruent. So I know this is an angle marked, this is a side marked, and this is another angle marked. This is going to be angle side angle. Okay. You know, the question is, they're going to mark exactly the same. So they can be flipped, turned upside down, backwards, whatever else. They just have the same sequence. Okay, so we have angle with a single mark in it is, so A and D are congruent. Side AB and side EC are congruent. That's my side. And angle B is congruent to angle E. This is my angle. So these are congruent triangles by angle side angle. Okay? And the last part of the trip is to get this congruency statement written properly. So we have to make sure we match up our angles to write the statement. So angle A this is given to us, angle ABC, and so it's ABC. We got to go over here and say angle A is congruent to angle D, so we got to put a D first here. And then angle B is congruent to angle E, so E has to go next. Which means the unmarked angle F is the last angle marked. It's F and C are congruent. Okay? Alright, so this next one here, let's see what we got here. Okay, if we look at this real close, I see I have a side congruent to a side. I have an included angle, congruent to included angle, and I have another side congruent to a side. So this is side angle side. So this is congruent by side angle side. And then to write our congruency statement, we got to match up our angles again. So angle M. Now here's how I do it. Angle M is on the side that goes from the marked angle to up the one marked side to the M. So that means that the marked angle, the one marked side goes to P. So M and P are the same size. So that goes P right there. N is from the marked angle up to two marked side, which means that the marked angle is R up to two marked side is Q, so N and Q go together, so there's got to be a Q. And the last one is the marked angle, O and R are congruent. Okay? You have to get these letters in the right order or they'll mark it wrong. Okay? Okay, the third version of this looks like this one here. And if you study this long enough, you see that there's only two marked pieces. Okay? So we only know that two sides are congruent. Okay, that are congruent. Therefore, we don't have enough information for this. We have to have 3 pieces, remember, and only have 2. So we have to say this is not necessarily congruent. Okay? All right. Our next part is our proof. Okay, and a 2-column proof is going to do this. We're going to have to prove that these triangles are congruent, that DEF is congruent to FGD. Prove these 2 triangles are congruent. And then, so we do a 2-column proof. And these are more fun on Alex. Okay, we need to have 2 columns. So here's my 2 columns. This statement, this column here is our statement column. And this is my reason column over here. Okay? So what happens is this. We're going to see if we can figure out, we know that DE is congruent to FG, so we're going to say DE is congruent to FG. I'm going to write that down right here, statement 1. DE is congruent to FG. I know that because it was given to me. Given information is always true. Okay? Okay, my second part, I have angle EDF, so EDF is this angle right here, and angle GFD, GFD is this angle right here. Those angles are congruent. I'm going to put that in my statement here. So I have angle EDF is congruent to angle GFD, and that's because, again, that was given to me. Okay, so I'm looking for my third piece. Okay, so I need to prove that the third piece is congruent. So I can't prove that E and G are congruent. There's no way that I can prove those angles are congruent. I can't prove that angle EFD and angle GDF are congruent. These angles here are congruent. There's no way to prove those are congruent. Okay, FE might be congruent to GD, but I can't be sure. But I do know that this angle, this side here, FD, is a part of both triangles, and that line being itself is a reflection of itself, therefore it's congruent to itself. So I need to write a third statement now that says, okay, FD is congruent to FD. Okay, and I know that because that's reflexive. Any line is congruent to itself. Okay, that's what that means. So now I have my third piece. So now I have angle, side, angle. Or sorry, side, angle, side, side, angle, side. So those are my 2 triangles. So statement 4 then, there's this statement right here that says triangle DEF is congruent to triangle FGD. And the reason it's congruent is because of side, angle, side congruency. Okay? That's how you do proof. You proved it. Okay, our last part is this right angle stuff. Let's talk about HL. We're going to talk about HL. To have HL, you have to have 3 things. 1, you have to have a right angle. Okay? That's the box in the corner. 2, you have to have a hypotenuse that's congruent. And the third thing you have to do is have a congruent leg. So if any one of those are no, then it's got to be answered no. So here we go. First question, do I have a right angle congruent? Yes, I do. That's my right angle congruent, that right angle. Okay? Second thing, my hypotenuse. This is my hypotenuse right here. I do not know if those are congruent. My leg is 36, so my leg's congruent, but I do not know if my hypotenuse is congruent. If I don't know that, then I have to say no. Okay? Alright, so over here. I've got my right angle. Yes. I've got my hypotenuse. that I know is congruent. It's marked with 2 lines so that I know they're congruent. And I have my other leg that's congruent. So this is yes. Okay. Third one. This is not a right angle, so I can't even answer the first question. These are not right angles, therefore this is automatically no. I mean, I don't care what else is in there. And my last one, these are definitely right angles. I have it marked right here and here. Those are my right angles. I have a congruent hypotenuse. It's the same line, so it's reflexive there. And I have congruent legs. So this is definitely a yes. Okay. Good luck with that one. So be very careful on a couple of things. Remember how you label and name your congruency statements. Just very careful. And make sure that you have all your pieces corresponding in the right places. So the corresponding pieces are right. So then make sure you have 3 of them. If you don't have 3 pieces, you can't do it. Okay? All right.